Hey guys, today we are working on Pythagorean theorem and distance formula. Our big learning target, what we're going to learn today, is to use this distance formula to find distances between 2 points. So Pythagorean theorem, it is a squared plus b squared equals c squared. What does that mean? A and b are legs of a right triangle, and so the legs are the two that connect together to make that right angle. So there's that right angle right there. And then we also have C, which is the hypotenuse, which is directly across from the right angle. So if you see here, that would be C. So here's the length of C. So if you look at this illustration here, this is why it works. So what Pythagoras figured out was that a squared plus b squared, adding those two together, that would equal our c squared. So that's what the theorem's all about. All right, let's try it out to make sure we understand how to use the Pythagorean theorem. So for this first one, we know that these are our legs, A and B, and it doesn't matter which order they're in, we just have to make sure that our C is our hypotenuse. So for this one, I'm going to plug it into our A squared plus B squared equals C squared. Then I'm going to calculate each of these, and I end up with c squared. Then I add those two like terms together. We get 144 equals c squared. So now we're going to take the square root of both sides, and we now know that c is 12. So hit pause and try the last two without me. All right, for the second one, you just had to be really careful that your a squared was your unknown, because we don't know what that A length is, but we do know the length of leg B, and then we do know the length of our hypotenuse, or C. So plugging that in, I found out that A would be 9. All right, hit pause, make sure you did that last one, check your work, and we'll see if you got the right answer. All right, for this last one, we had to figure out the length of this side of the triangle first in order to solve for our x value. So to solve for the length of that side, I worked it over here, and I found that 5 squared plus b squared equals 13 squared, because 13 was the hypotenuse, and solved to figure out that b was 12. So if the length of that leg was 12, then I know that I can use that along with the leg that we already know in order to solve for our x. Plugged those in and solved that x is 37. All right, for these two, what I want you to do is use the Pythagorean theorem to see if you can prove whether or not these are right triangles. Don't just eyeball it, because they're not drawn to scale, so you can't really use that method, but I want you to see if you can use the theorem to prove whether or not these are right triangles. So hit pause, try it out. All right, for this first one, we know that the hypotenuse is your longest length if, in fact, this is a right triangle, and so we would plug in for a squared plus b squared equals c squared, and we end up with 2025 equals 2025, and since our a squared plus b squared did, in fact, equal our c squared, then we know that this is a right triangle. Yay! All right, let's see if you got the next one correct. All right, for this next one, I looked at this and I found that these were my two legs, and my longest length was my c squared, or c squared if it is a right triangle. So I plugged in a squared plus b squared equals c squared, added them all up, and I found that my a squared plus b squared did not equal my c squared. And because of that, we know that this is not a right triangle. All right, how do we find the distance between 2 points? So let's look at AB first. So if I want to find the distance between AB, so this line right here, so I want to find the length of AB, what I can do is we just count. So if I look at this, I go over -7, or I go 7 because it's distance, and distance is always absolute value. So I go over 7, and then I go over 8, so length of AB is 15. So then if we do it for this one, down here for R and S. So if I'm finding the distance between R and S, we would find that we have a distance of 4 up here and then a distance of 5 below the x-axis. So RS equals 9. All right, so those first two examples were pretty easy because they were on a vertical and horizontal line. What happens if you're trying to find the distance between 2 points and they aren't on a horizontal or diagonal? What we do is there's 2 different ways to solve this, 2 different methods, and I'm going to show you both of those. The first one we're going to look at is how you could use the Pythagorean theorem to help you figure that out. So what we would do is we would create our right triangle. So, for example, I'd walk over from one point and then I'd create my right triangle. So if I find the distance of this triangle, this first one, the length of this line to this point is 9, because we went from -5 to 4. And then the length of my vertical line here is 8, because I went from 1 up to 9. And then we're going to use the Pythagorean theorem to solve for our hypotenuse, or our C. So we plug that into our Pythagorean theorem, 8 squared plus 9 squared equals C squared, and we would solve that 145 equals C squared. We take the square root of both sides and we end up with square root of 145 equals the square root of C squared. Sorry, I can't get that squared on there. And then we would take that and solve. We could either leave it as C equals square root of 145, or we could say that C is about 12.04. The second way to solve these types of problems is to use the distance formula. So here is the distance formula. It looks crazy, but it really does make sense when you think about it. So here's where it comes from. So we have our Pythagorean theorem over here, and we know that a squared plus b squared equals c squared. Well, if a squared plus b squared equals c squared, then c equals the square root of the quantity a squared plus b squared. If we just took the square root of both sides of the Pythagorean theorem, this is what we'd end up with here. So if we think about this big idea here, we really have our triangle that we're creating. Our A, our leg for our A, is really the distance from our x sub 2 minus x sub 1. And we're just looking at that is the length of A. And same thing for our y's. We have our y sub 2 minus y sub 1. That's really just the length of B. And so if you find the length of A, add on the length of B, and square both of those, and take the square root of all of that, you end up with the distance formula. It sounds confusing, but it really isn't. Let's practice and try it out a little bit. All right, so let's find the distance between these 2 points using the distance formula. So I have the distance formula written there, right there. You have to first determine which one is going to be your x sub 2, y sub 2, and which one's going to be your x sub 1, y sub 1. It doesn't matter. It ends up to be the same thing if you use one as your sub 2 or the other one as your sub 2. It doesn't really matter. So I'm going to label this one as my sub 2 and this is my sub 1, just so that I remember and I don't get them mixed up. So then I'm going to rewrite my numbers in to figure out the distance. So my x sub 2 is 6 minus, and then my x sub 1 is -4. Be really careful if you have a negative in there that you don't ignore it. And then my y sub 2 is 5 minus, and my y sub 1 is, it's 2. And squared. Then I'm going to solve that. We get d equals, 6 minus -4, that's 10 squared, plus 5 minus 2 is 3 squared. D equals the square root of 100 plus 9, which equals the square root of 109. You could keep it as the square root of 109, or you could say that d is about 10 and 44 hundredths. All right, now let's try to find the distance between these 2 points using the Pythagorean theorem. So if I was going to do it that way, I would find my 2 legs. So the distance between this, our starting point, to there would be 10 because it's -4 and 6. So we know that that's one of our legs. So I'd say 10 squared. And then our other leg would be right there. And I'd figure out that the distance is 3 squared equals, and then we're trying to determine our c squared. So that one is 100 plus 9 equals c squared, 109 equals c squared, and we get the same result. All right, for these 3, use whichever method you like best and see if you can figure out the distance between these 2 points without graphing it. All right, for this first one, I used the Pythagorean theorem, and so I found that C was about 7.21. All right, for the middle guy, I solved him using the distance formula, and I plugged in my values for x sub 2, x sub 1, y sub 2, y sub 1, and found the result was the distance between those 2 points was 13. And for the last one, I used Pythagorean theorem to solve this one, and so I found the distance between our x values, I found the distance between the y values, so those are the 2 legs, and that was d squared, which is the hypotenuse, so the distance between the 2, and I solved that that would be 29, and that's about 5 39/100ths. And finally, I just had to. Everyone loves a good right triangle joke.